What's up, clubbers? GM. In today's video, what we're going to learn is how do we use an NFT smart contract and make it upgradable and sort of deploy it to a local testnet and use it, upgrade it, see how it works, how the workflow works. I've already discussed how do we create an upgradable smart contract from scratch in my previous video. So if you haven't checked that out, please make sure to go and check out that video. It sort of will help you understand the concepts in this video. And just to gain some sympathy from you guys, my hand is not working. My right hand is not working. I have tennis elbow from playing badminton. I don't know how one does that, but I did that. So yeah, most of my hand gesturing will be from left hand for I think the next couple of months at the very least. I will also be typing like this. If you're feeling a little sympathy, please make sure to hit that like button on this video and subscribe to this channel if you haven't. If you want me to read any message, please leave it in the YouTube comments. And if you have any question, come join my Discord server. There are a bunch of people just like you and me who are there helping each other out. Alright, with that said, let's get started. So as always, we have opened our OpenZeppelin Wizard. And we have selected ERC721, which is the NFT standard for smart contracts. I've usually used this approach to create a new NFT. So what I will do is select a name, symbol, base URI, whatever, make it mintable with auto increment IDs. The one thing that I will do different in this video is go down and select UUPS upgradability. I've discussed UUPS upgradability in my previous video, the one I had mentioned earlier in this video. So please make sure you check out that video, check out the gotchas and everything, so that you can actually understand what's going on. So I select UUPS, and suddenly there's a bunch of code over here because a lot of things are not straightforward as they were without the upgradability. Now, one thing that you will realize is that the open and remix button is sort of disabled. It's not really disabled. If I hover on it, it says open and remix anyway, but remix does not play well with the upgradable smart contracts. So what we are going to do is we are going to use something called Hardhat. Now Hardhat is a development environment for smart contracts and Web3 related projects. There's another environment like this which is called Truffle. If you're more comfortable with that, feel free to use that. In today's video, what I'm going to discuss is how do we use Hardhat and deploy an upgradable smart contract. Alright, so what I'm going to do is I'm going to copy this code in a while. But before that, let's set up Hardhat. Now for Hardhat, you need to have something called Node.js and npm installed. To set up that environment, you can just go through this guide. I'm not going to do that. I've already done that. And I believe most of you who are watching this video, if you're a developer, you should know this. And if you're not, like, just follow this guide. It's not that difficult. And also just go get some programming experience first before deploying such complex things. Alright, so just follow this guide and you'll understand how do we install Node.js. Once you're done that, I have opened my old folder. This folder was the one that I had disused in my previous video where we were just upgrading a smart contract and working with the UI. So I have written some readme code. I'll make sure that this is available for you. The first thing that we need to do is run npm init-y. The -y means that I accept everything. If you just want to read through it, don't add the -y and just read and give your own options. But -y is generally nice. So I'm going to do that. And once I have the package.json, next thing that I am going to do is npm install --save -dev hardhat. So npm install --save dev hardhat. This installs Hardhat for me as a dev dependency, as a local dependency. So I press enter. It'll take a little bit of time, or maybe it's just because I have a slow internet, but it is what it is. Alright, once Hardhat is installed, what I'll do is write npx hardhat init. I've also shared that code over here. And I'll press enter. And now it'll ask me, do I want a basic sample project? What do I need and stuff? So let me just go ahead with a basic sample project. The root is fine and I want to add a git ignore file. Now it is asking me if I want to install other dependencies for Hardhat. What I'm going to do is I'm going to say yes. Again, now this will take some time because it's installing those dependencies. Generally, I prefer Yarn to do these things. I'm just using npm because it is easier for you for the person who has not done this before, but otherwise Yarn is the better option, I believe. Alright, once everything is installed, this is what the screen will look like. Now we go back and select npm install, and then there are a bunch of things. So these are for adding the upgrade plugin from the OpenZeppelin library, from the OpenZeppelin repository actually. So these help us upgrade, give us basically some objects with which we can upgrade a specific smart contract. Like this gives us a way to deploy a proxy smart contract and upgrade the proxy smart contract. So I'm going to paste it here and press enter, and again wait for it all to finish. Alright, and now you're done adding stuff from the terminal. The next thing that you will do is go to hardhat.config.js, and now one thing that you need to add is basically require here the Hardhat upgradable plugin from OpenZeppelin. So to do that, just add an enter over here, add a return, and then write require, and then in the quotes OpenZeppelin / hardhat -upgrades. This is the name of the plugin that we are going to use. Alright, make sure to hit the save button and done. Now let's go here and check out the contracts folder. In the contracts folder, there is a greeter.sol. We will not be needing this, so I'm just going to remove this, and I'm going to go back to our OpenZeppelin Wizard, and then I'm going to copy the code to clipboard, and then I'm going to paste it over here and hit the save button again. Just so that I don't go crazy, I'm going to rename this to MyToken.sol. I believe this is what the code will look like for you as well. We are using an ownable extension, and so that is why we get this only owner modifier, and we are adding this function called authorize upgrade, and this can be only called by the owner. If you don't want the owner but you need something else, just remove the only owner over here and add the valid requirements here on this line basically. Alright, so I'm going to leave it at only owner because I need an owner, but if you needed something else, just remove that and add whatever required statements you want to add. Now one more thing that I want to do is basically remove the counter plugin, because I just want to have my own uint256 counter. Alright, and I will make this public and change the name to count. Alright, and here change the token ID to count ++ count. Alright, so this way we will increase the count and then give token ID the value. Alright, so this MyToken NFT looks fine. So the next thing that I'm going to do is open the terminal again and write npx hardhat node. Now what this does is it starts a blockchain node here on my own machine. So I can just press enter, and suddenly a blockchain node has started, and it has seeded 20 different accounts with about 10,000 ETH, and it has the account in the private key. Make sure you don't use these private keys anywhere, because these are public, and if you send any funds, they can be lost. So I'm going to go to MetaMask, and I'm going to select localhost 8545 over here after starting the node. Alright, and then I have already copied the private key, and I'm going to click import account and then paste the private key over here and import. And if it is connected to localhost port 8545, the account 3 will, whatever account actually for you, this account, the imported account, will have 10,000 ETH as its balance. Great. The next thing that I'm going to do is write npx hardhat console and then a _network and then localhost, which means run a console and connect that with the localhost, the node which is running on the localhost. So I press enter, and it is going to compile our contracts and then give us this node. Oh, I made a mistake. I haven't removed this, even though I removed the upgradable. So I mean, this should work now. All right, so it is working. So let me just type my token equals await ethers. So ethers is directly injected into our console by Hardhat. All right, so ethers.get contract factory, and then in the contract factory, what we are going to do is send the path to my token. We don't need to add contracts in front because that is sort of provided by default. So I just need to write my token and then close the brackets. Now if I press enter, I get the MyToken, which is a contract factory, as you can see over here. Now I can deploy this. Now to deploy this, it is just MyToken dot deploy, and we can await this and it will deploy the MyToken for us. But we want to deploy an upgradable proxy. So to do that, if you have added this OpenZeppelin Hardhat upgrades, what it does is it gives us this variable called upgrades, where we have this function called deploy proxy. All right, now in deploy proxy, the first thing that you enter is the contract factory, and you can just go ahead and deploy, but this will give you a transparent proxy, which is not something that I've discussed, and it's not something that I advise you to use. So I just add the await at the in the front, and then another thing that I will need to do over here is send an options object. Now in the options object, I need a key called kind, and the value will be UUPS. All right, so this will give us a deployed proxy, which we can store in a variable called u for upgraded, or actually let me just store it in a variable called empty for my token. All right, so empty, I get the contract address, so I can also get empty dot address, and it will give me 0xe7f1 whatever. All right, another thing that you can see is that we have spent some gas from this account for deploying this proxy. Now the thing is, we have not just deployed one smart contract, which is for proxy, we have also deployed the implementation smart contract, and you can see over here in the node there are two things that we have deployed. The first is the MyToken with a different address, and then the proxy, which is an unrecognized contract with this address. All right, so let me just copy the address from empty and just paste it in my file, in this specific file. This file basically helps me connect to the network using JavaScript, and then we get some methods that we can call. Now in the current value, we basically call this method called count, which we have in our smart contract. So what we're going to do is, once we connect, we call this method called count, and then we set that value over here. So let me just start a server here, and now I am running this at port 8000. Now just make sure that you're connected to the local host 8545, and then you click on connect. All right, so this time it is getting a current value which is 0. And why is it getting that? Because we haven't minted anything. All right, now let's go ahead and mint something. Okay, so let me just go ahead and go to npm to the console that we have opened, and here write empty dot safe mint, and then we can just copy our own address, paste it over here, and press enter. So I can just click again get current value, and this should have changed by 1, and just like that it has changed by 1. All right, it has been added, it has added 1 to it. Now the problem that I see over here is that safe mint is an only owner function, only the owner can call it, and that is a big problem for us. Why? Because the users cannot mint any NFTs over here. Also, we have not made this function payable. So another problem here that we have is that nobody can pay us for minting this. Next thing that I want to do is create my version 2 of this smart contract. I'm not going to do it payable because that is not something that I'm trying to make you understand. But what I'm going to do is remove the only owner bit over here and let users mint NFTs for themselves. There's no limits or anything. Now, one thing that you need to make sure is, if you have inherited any libraries, you cannot change them or change their orders. The problem is that any sort of change will change the variables in the slot, and that will cause an issue. How variables work over here is that they are stored in the proxy smart contract, but the logic is written in an implementation smart contract. So the slot in which the implementation smart contract stores the variable, that is the slot in which the proxy smart contract stores the variable. But if we upgrade to a new implementation smart contract and the slots are not the same, it will just read old slots from our proxy smart contract, the smart contract which we give out to users, and it will see that it does not have access to the correct variables. All right, so that will be a problem. So now what we have to do is we have to make sure the variables are in the same order. If the initializable variables the variables from this initializable class will be the first to take the slots, then 721 upgradable, then ownable, then UUPS upgradable, and then the count. So if you want to add a new variable, so you will not put it above count but below count. I hope that is clear. Now in this specific contract, I have my token. I'll just change this to MyToken2 and save this as MyToken2.sol. The next thing that I've done is I've removed the only owner from SafeMint. Now before I upgrade, what's up again? I'm so sorry, I lost all the audio in my previous recording, so I'm just having to re-record it again. So I'm just going to pick up from where I left off. The values might be a little changed, like for example the address might be different, but don't worry, like you can still follow along the tutorial and you will end up at the same result. Okay, so the next thing that I want to do is try to mint an NFT from a non-owner address. So that address for me would be my own address, because that is not the owner of this smart contract. So to do that, first I need to basically change the ABI. The ABI right now in this file is for an older video. So what I'm going to do is I'm going to go to artifacts and then contracts and then mytoken.sol, and then there I'm going to select mytoken.json. Now here there's an ABI object, just need to copy that and then come here and paste it, like basically remove the old ABI with the new ABI. You don't need to do that, you will get the new ABI directly in this file. So we save this file, we go back and we refresh. Alright, so now we have this contract object which is null because I haven't connected. Once I have connected, we have this contract object which has a method called SafeMint. Alright, and this accepts an address. Alright, and I await this and .send with the gas being paid by the account, the connected account. So I press enter and you can see that there is an error. It says the transaction is expected to fail. Trying to execute it is expected to be expensive but fail and is not recommended. Now why is that case? Because right now only the owner can mint this. So to fix that, what we have already done is we have created this MyToken2. We don't have an only owner over here, and now we are going to upgrade the proxy. To do that, first I shut down my console and I restart the console again, which will connect to the local host. And now we write await upgrades.upgrade proxy. The first thing that it accepts is the address of our proxy. I'm going to copy the address and paste it over here. And the next thing that it needs is the the new token factory. Now, unfortunately, I haven't received that factory yet. So what I'm going to do is just create the new factory. I am just calling it MyToken2 await ethers.get contract factory, and this will be MyToken2. By the way, in the beginning of the video, I said that this will be the path, but actually it will be the name of the contract. That is what will appear over here, and that is what we will basically read. Alright, so now I press enter and I have received the contract factory. The next thing that I do is await upgrades.upgrade proxy with the address being the address of the proxy, and next we put in our contract factory, which is MyToken2. Alright, I press the enter button and hopefully this has now upgraded our proxy. Now how do we test it? To do that, just refresh this page, connect again. You can see that the current value is still 1. If I click it again, it is still 1. And the next thing that I will do is just call contract.methods.safemint with the account as my address, and then pay the gas from this account again. Now this time you will see that there is no error, and if I press confirm, the transaction should go through. And the transaction has gone through. If I click on get current value, the value will update to 2. Alright. So off the camera, what I'm going to do is remove this increment and call it a mint button, and just you can move forward with that. Alright, I've done the necessary changes, and if I connect again, it says mint, and if I click on mint and the transaction, I let the transaction go through, the value changes to 3 now. So this is how you upgrade an NFT smart contract using the Hardhat CLI. All right. Now, what if you wanted to do this on a real network, on let's say Ringkeby or something like that? So to do that, what you need to do is go to hardhat config.js and then basically create a network over here. All right, let me just call it mainnet, and this network, whatever name you put in, that is the name that you will send as the argument when you're trying to start the console. So what do I mean by that? When I was starting npx hardhat console, I presented a network called localhost, which is the local node that is running on my server. So instead of that, what you're going to do is going to use a double hyphen network, and then whatever name that you provide over there, let's say mainnet, Ringkeby, whatever. With the network name, you also will provide a URL, which will be an RPC URL. So you can put any of the RPC URLs over here. It can be Alchemix, Infura, or whatever any other node that is running out there, or even if your own node if you're running. And then you can also provide an accounts array, and in the array you can just put, let's say, the private keys with which you can run those transactions, run the deployments. I'll link to some important things in the description below, which will basically let you know how do you connect to a remote network using Hardhat. And that is it. This is basically how you create an upgradable NFT smart contract. If this was in any way helpful, please make sure to hit that like button and subscribe to this channel if you haven't. If you have a future video suggestion or want me to cover a specific topic, please leave it in the YouTube comments. And if you have a specific question, come join my Discord server. There are a bunch of people just like you and me who are trying to help each other out. I hope this video was helpful. I hope to see you again next week. Till then, take care. Bye-bye.